Single evaluation metric means that instead of using precision and recall differently, we can find a formula which uses both precision and recall, which is known as F1 score. So F1 score is the harmonic mean of precision and recall, which is the formula is 2 divided by 1 upon precision plus 1 upon recall. So the another method to tune your hyperparameters is optimize one parameter and satisfy others. So it is not possible that you can satisfy everything in your artificial intelligence model. So many times we say that we have one primary parameter and other are secondary parameter. So we will try to optimize the primary parameter and only try to satisfy, not optimize the other parameters. So for example, if we are using a classifier, then uh, we are looking at accuracy, we are also looking at running time, and we are looking at the safety of that algorithm. So let us say we are saying that a classifier A that we have developed is giving 90% accuracy, but running time is 20 milliseconds, and so on. So if our primary parameter is accuracy, then the other parameters can only be done to the level of satisfaction. For example, we will say maximize accuracy subject to running time less than 50 millisecond and safety should be yes. So like that. So we are not trying to optimize the running time. We are only trying to keep the running time below a particular threshold. So few of them can be satisfying metric. For example, if we say that running time needs to be minimum 100 millisecond, then running time is satisfying metric and accuracy can be optimizing metric. Similarly, in some cases we may try to minimize false positive, and in some cases we may try to minimize false negative. For example, let us say if you are using Amazon Echo in your home and you are using different words for making it wake up. So false positive means the frequency with which the system will wake up even when no one is calling the system. So no one is calling your Amazon device and it is automatically start singing a song or doing something. So that is false positive. False negative means how often it fails when you are trying to wake up. So you are saying wake up Alexa, but it is not waking up. So that will be false negative. So depending upon your application, you may either try to minimize false positive or false negative. Similarly, this you need to understand the importance of dev set and single evaluation metric. So if your team improves the classifier accuracy from 95 to 95.1%, you might not be able to detect that 0.1% improvement from playing the app. For example, the user of a application will never know that whether the actual instance of the input that he is trying to test on the app that falls under zero point 0.1 additional uh, accuracy that has come into the system. So it is only for the developer of the system to understand the accuracy. It is not basically for the user. So having a dev set and the metric allows you to very quickly detect which ideas are successfully giving you small improvements, and therefore lots you quickly decide what ideas to keep refining and which ones to discard. So many times the metric evaluation may fail also. For example, suppose that you are working on a cat and dog application and your metric is classification accuracy. So this metric currently ranks classifier A as superior to classifier B. For example, it says that A is let us say 97% accurate and B is 80% accurate. So definitely you will say, okay, I will take A because it is 97% accurate. But people may find a problem that this A classifier, when it is saying it okay, it is also finding some pornographic images as cat images. So this kind of classification of pornographic images into cat images can just destroy your system in the market. No person will use it. So in that case, there is no meaning of higher accuracy if you are getting such kind of problem. So this is the example that when your metric evaluation can also fail. So it is important that you start quickly, then optimize. So means what is important when you are building a AI model, It is not desirable that you start with a optimal scenario. The desirable thing is that first you start up with a working AI model and then slowly and slowly you optimize it. So that is the most important thing to learn from this. So then you have to also do many of the manual analysis of your classifier many times. For example, uh, what we mean by manual error analysis is, for let us say you are finding few dogs as cats by classifier, means your classifier is saying that this particular dog that you are seeing in the picture, he is saying that this is a cat. So actually it looks like cat also, but it is actually both are dogs. So when you do your accuracy analysis, you find out that the accuracy is 90%. Then you do the error analysis. So let us say the total number of training set is around 10,000 images. So when you do the actual error analysis, what you see is that 100 random mislabeled dev set examples are there. So and then you find out how many dogs are there. So if there are only 5% of them, that means you are only affecting 0.5% due to that particular issue. So that means you, even if you remove this issue of dogs being found out as cats, still you, how much improvement you will make in your system. So like this, we do a manual error analysis. We take each of those images and we say that how it is categorizing. So if it is categorizing it as a dog, then what kind of dog it was, or it was a cat, or it is a blurry image. So like that, we do a manual analysis of our training set, and we find out that why it is giving less accuracy. So there are few more points. So whatever process you apply to fixing dev set labels, remember to apply it to the test set labels too, so that your dev and test set continue to be drawn from the same distribution. And if you decide to improve the label quality, consider double checking both the labels of examples that your system misclassified as well as labels of examples it correctly classified. So it is very important because most of the labeling is done by human labelers, and there can be errors in the labeling itself also. Means there was one image which was actually a dog, and it is classifying it as a cat. But when you saw it, you saw that the label was also cat. So there can be a double error or there can be single error. So in that case also you need to check the labels of your work also. So these are the few hyperparameters that we are covered. There are many more hyperparameters like momentum, then you have learning rate, then you have regularization. So probably we can cover in some other session in some other time. So let us see if you have any questions till this point. Any questions on any research work you are doing, anything, any problem you are facing in some data set or in training your model or in getting the right accuracy, please go ahead and ask any question. Yes, we have Sri Lakshmi Kona. Yep, speak up.
Good afternoon, sir.
Good afternoon.
Sir, actually, I am doing the research in the. Sir, I'm sorry.
Yeah, you are audible.
Okay. On the medical data, diabetic retinopathy. So, in the literature review, most of the cases people are using the green channel, green channel data. They are taking the RGB input, RGB images, but they are extracting the green channel. Is there any specialty in the green channel? Only randomly they are selecting. We have the L channel also, no? Which one is the better?
No, actually the magic of the deep learning is that you don't need to select anything. So if
Okay.
the deep learning model, it will see that the classification is coming better with any particular features, then it automatically will pick up those features. So that is the beauty of choosing different hyperparameters properly. That if see, when we are using these hidden nodes, and we also try to uh, hide some of the hidden nodes, So in that case, those hidden nodes which are having lower weight values, which are even below certain threshold and closer to zero, they are automatically taken away. So those
Okay.
things are there. So you have means this dropout you have, which is specifically to prevent this kind of problem.
Okay, sir.
So you don't need to concentrate on that what you are getting, whether green channel or blue channel. What you should concentrate is that you have a quality data, and then you apply your hyper tuning parameters properly, so you will automatically get the desired result.
Okay, sir. Thank you, sir.
Yes, anyone else, please? We can have 2-3 more questions.
Thank you very much, sir. It was a spectacular session, and I request all the participants, if still you have some queries, you can bring the mic to ask the queries. So, any participant?
There is one question from Jaima.
So you can share my email also with the participants. If they have any questions, they can write an email to me later on. And I will also
Yes, sir,
share
sure.
this slide also. There are few more slides that we could not cover up, so which have the detail of other hyper tuning parameters. So they can go through that. Even if there are any questions, please, you are welcome to come back. Yes, Dr. Haima, please speak up.
देखो उनका ऑडियो ऑफ होगा, मधु उनका ऑडियो ऑन कर दो, जो क्वेश्चन पार्टिसिपेंट पूछ रहे होंगे. Madhu, no audio is coming.
Okay, probably Dr. Haima can
Yes.
send an email to me later. So,
No
Professor
problem,
Madhu,
sir.
you can.
They can write you, Anna,
Yeah.
whatever the questions they have, and
Yes.
even there is no need to remember the email ID. Even in the Google search, just put Dr. Deepak Garg and Bennett. You can get everything regarding deep learning. And sir has no doubt from many years working in this area only. And deep learning की popularity में Dr. Deepak Garg has a great help for us. So we are really grateful to him.
Thank you, Professor Pandey. Okay, so we can close the session. Thank you very much.
Yes,
Thank
sir.
you very much, sir.